In the second video, we discussed borrowing bits. In this video, we'll determine the possible host addresses that are usable. Now that we know that we need to borrow 3 bits for our scenario, and that our custom subnet mask is 255.255.255.224, we have enough information to fill out the following table. The very first IP address in our Class C is 206.207.208.0. Since we're only working with the last octet, we'll just represent those 8 bits in this table. We said we borrowed the first 3 bits for use in the network portion of the address. Everything to the right of our imaginary line is used for the host portion of the address. So those 5 remaining bits are represented here. 0 as the first address in decimal can be written out in binary by 8 zeros. Remember the definition of a network address? It's one where the host portion of the address is represented by all binary zeros. So this is not a usable address. This cannot be assigned to a host. The very next available IP address is .1. That can be written out like this. Since there's no longer all binary zeros in the host portion of the address, we know that that's a usable address, and we can fill it in on our table. The next available address is .2, so we write that this way. Again, this does not have all zeros in the host portion of the address, so this is a usable address. We could continue writing out the numbers in binary until we have a number that has all ones in the host portion. Remember that when an IP address has all ones in the host portion, it's the broadcast address, and it can't be assigned to a host. Let's write out the broadcast address for this subnet. Remember that a broadcast address occurs when we have all binary ones in the host portion of the address. If we add up the value of all these bits, we come up with 31. So the broadcast address for this subnet is .31. We know that we can't assign the broadcast address to a host. We can, however, assign .30 to a host. Here's what .30 looks like, written in binary. Since we do not have all binary ones in the host portion, we know that this is a usable host address. So we can fill this out in our table. Okay, so we said the host range goes from .1 through .30. The broadcast address is .31. And we said that the first subnet is unusable since it contains the wire address for the Class C network, so let's mark it as unusable. Great. Now we're ready to start working on the next subnet. The last number of the first subnet we worked on was 31, so the next decimal number is 32. And that would look like this. You should notice something about the host bits. They're all zeros. This means that .32 is the network or wire address. Remember that we can't assign a wire address to a host, so let's write that in our table. We could work through the exercise of writing 33 in binary, and then writing 34 in binary, and so on, until we come up with a number that has all ones in the host bits, which is the broadcast address. Let's take a shortcut and just write out that broadcast address. So we'll put all ones, and if we would add that up, we would have the number 63. So 63 is the broadcast address for our next subnet. So let's put that in our table. So the network address is .32. The first host IP address is one number greater than .32, or .33. The broadcast address is .63, so the last available host IP address is one number less than that, or .62. So what would the network address of the next subnet be? It would be one number greater than .63, or .64. We could continue to work through each of the subnets using the manual method of writing down the number in binary and then filling out the table. But it's time for another subnetting rule. We should notice a pattern forming here. We start out with .0, then go to .32, and then .64. we're incrementing the network address by 32 in our scenario. The last rule of subnetting gives us a quick way of calculating the increment. The fourth rule of subnetting tells us that the decimal value of the last bit borrowed gives us the increment of the network address in our subnets. Since we borrowed the first 3 bits, the decimal value of the last bit borrowed is 32. So we know that we increment the network or wire address of our subnets by 32. So the network address for subnet 2 is .64. We add 32 to that to get .96 for subnet 3. 96 plus 32 is .128 for subnet 4. 128 plus 32 is .160 for subnet 5. 160 plus 32 is 192 for subnet 6. And 192 plus 32 is .224 for subnet 7. Okay, that was pretty easy. The next step is to write down the broadcast address for each subnet. The broadcast address is also incremented by 32, so we could add 32 to the last broadcast address that we calculated, but there's an even easier way. Let's take a look at the pattern that's forming for the broadcast address. The network address of subnet 1 is .32. The broadcast address for subnet 0 is .31, or one number less than the next subnet's network address. The broadcast address for a given subnet is one number less than the next subnet's network address. So once we've written down the network address in our chart, we can easily write down the broadcast address. The network address of subnet 2 is .64, and we've already calculated that the broadcast address of subnet 1 is .63. The network address for subnet 3 is .96, so the broadcast address for subnet 2 is one number less than that, or .95. The network address for subnet 4 is .128, so the broadcast address for subnet 3 is .127. The network address for subnet 5 is .160, so the broadcast address for subnet 4 is one number less than that, or .159. The network address for subnet 6 is .192, so the broadcast address for subnet 5 is .191. And the network address for subnet 7 is .224, so the broadcast address for subnet 6 is .223. So how can we figure out subnet 7's broadcast address? We could add 32 to .223 to come up with .255, or we could use our knowledge of binary numbering to know that the maximum number we can write with 8 binary digits is .255. We said that the last subnet, subnet 7, is unusable because it contains the broadcast address for the Class C network. So let's mark it as unusable. All the other subnetworks are usable, so let's record that. The next step is to calculate the host range for the subnets. Okay, so we already calculated out subnet 1 the long way. The network address is .32. We said the first available host IP address is one number greater than that, or .33. The broadcast address for subnet 1 is .63, and the last available host IP address is .62. So let's look at subnet 2. The network address is .64, so the first available host IP address is one number greater than that, or .65. The broadcast address for subnet 2 is .95, so the last available host IP address is one number less than that, or .94. Subnet 3's network address is .96, so the first available host IP address for subnet 3 is .97. The broadcast address for subnet 3 is .127, so the last available host IP address is .126. Subnet 4's network address is .128, so the first available host IP address is .129. The broadcast address for subnet 4 is .159, so the last available host IP address is .158. Subnet 5's network address is .160, so the first available host IP address is .161. .191 is the broadcast address for subnet 5, so the last available host IP address is .190. Subnet 6 network address is .192, so .193 becomes the first available host IP address. .223 is the broadcast address, so .222 is the last available host IP address. And subnet 7's network address is .224, so the first available host IP address is .225. And the broadcast address is .255, so the last available host IP address is .254. Remember the fourth rule of subnetting? It told us that the decimal value of the last bit borrowed gives us the increment of the network address in our subnets. In our scenario, this value is 32. This is the increment in our network address for the subnets. It also tells us the network address of our first usable subnet. Once you learn these rules, it makes it much easier to create custom subnet masks and calculate the addresses for the subnet. Let's review the 4 rules of subnetting. The first rule of subnetting tells us that we have to borrow at least 2 bits and that we have to leave at least 2 bits for the host portion of the address. The second rule of subnetting tells us that if we raise 2 to the power of the number of bits borrowed and then subtract 2, this gives us the number of usable subnets. The third rule of subnetting tells us that 2 to the power of the number of bits remaining minus 2 gives us the number of usable hosts per subnet. And the fourth rule of subnetting tells us that the decimal value of the last bit borrowed gives us the increment of the network address in our subnets and the network address of the first usable subnet. The rules of subnetting apply to Class A and Class B addresses as well. In the next video, we'll subnet a Class B address.